Hey, so today we are gonna solve problem B of Meta Hacker Cup round 1 2024. The problem B is prime subtraction. So basically we are given an integer n and we have to tell how many n subtractions are there up to n. And what is an n subtraction? N subtraction is a prime number which can be written in the form of two uh, difference between two prime number. For example, 3 3 can be if n is up to 5, so 3 can be written as difference of 5 and 2. 2 is also prime, 5 is also prime. So if n is greater than 5 or equal to 5, then we can take 3 into account. But notice how if n is 4, um, since we can only take number up to n, so we won't be able to take 4 5. So when n is 4, 3 won't be part of the set. 3 will become part of the set only after n equal to 4, n equal to 5. So firstly let's take the input. There are basically only two input. First one is t and the second one is a single integer n. So yeah, so now notice we will be given n, so up to n we have to tell how many n subtractions will occur, and also both the numbers should be less than n, whose difference will be that prime number. So let's write some prime number to get an idea. So these are first few prime number. So one thing you will notice that all prime numbers are odd except the first one, 2. So one observation is if we take difference of two odd number, that will be an even number, so that can never be a prime number. So only subtracting 2 can be useful, because we have to subtract from prime number and the resultant should also be prime number. So if we subtract any other one, if we just like forget 2 for once and try forming with using only this, it's never possible, because it will always be divisible by 2, since any resultant by subtracting any two of them taken as a pair will be an even, and that will always be divisible by 2, so it won't be prime number. Now for in case of 2, for example, so basically like if we can check if a prime number minus 2 is also a prime number, then that one counts. For example, 5 minus 3 is a prime number, so 5 counts. 7 minus 2 is a prime number, so 7 counts. 11 minus 2 is not a prime number, so 11 won't count. 13 minus 2, 11 is a prime number, so it counts. 17 minus 2, 15 is not a prime number. So basically that's how we have to proceed. And in the starting, just we have to take the consideration up to 4 there will be no one, on 5 there will be 2, and after that they will be increasing as we reach. For example, for a n, we find the last prime number which is less than or equal to n, and then okay, so the first thing we notice is that we need all the prime numbers. So how can we create a prime number? We can use the sieve of Aristotle method. So that what is the limit on n? So it can be 10 raised to 7. So let's take it somewhere like that. Now we will create a vector. Here we go. Vector in prime n. Okay, so initially we mark all as prime number, and now we know 0 is not prime number, 1 is not prime number. Now we start with 2. Now if I is prime number, we mark all the multiples of I non-prime, because if I is not a prime number, then sum of multiple of I would have already marked it non-prime, so we only need to mark the multiples of prime number as. So let's write j is equal to, while j is less than equal to n and j plus 0 I. So basically this is the pre-computation we have done. Now we will pre-compute the answer array for all the n initially. So initially initialize all to 0. Up to 4 it will be 0 only. From 5 we will start. An answer of 5 will be 2. So from 6 we will start. Okay. So obviously answer of I, it will contain all the numbers which have occurred in the set of 5. Now if a new number can occur or not, we will check this, right? If the current number should be prime and current number minus 2 should be prime. In that case only we there's a new addition at that point. For example, at 7 there will be addition of 5, so it will satisfy this condition. 7 is prime, 5 is prime, so answer I plus plus. So yeah, now all the computation is done. Now for each test case we can just print case x, and all we need to print is answer of n, and we are done. It should work. So yeah, it does work. If I wanna try some other test cases, so this is the input we got. Let's try this one. So yeah, this is the correct code indeed. For example, you can check manually. For 1 there won't be any, 6 there will be 2, 7 there will be new addition of 5, and so on. The time complexity will be n log n, where n is this for pre-computing, and for each test case it's just taking off one only. So all the time complexity is for pre-computing. So yeah, this code will pass. So yeah, this was it. Thank you.